Completed this 1/44 scale plastic model of the Artemis just in time to make a video before the launch. Welcome to my second video as a space fan. The kit that I just completed is made by Airfix. Pretty nice kit. It's the only one in 1/44 scale as far as I know. The setup I have there, the launch tower is not for the Artemis, but it kind of represents what's there, and the same thing with the mobile launch pad. Those are from 1/44 scale space shuttle model kits that I have. They add a little extra touch there. The actual launch utility tower, or LUT, is about the same size as the Apollo one. I think it's got 18 different stories. The shuttle had 15. The Artemis consists of the lower stage, also known as the Space Launch System. It's made by Boeing. It is powered by 4 RS-25 rocket engines, each one with approximately 500,000 pounds of thrust. They are actually left over from the space shuttle. They reuse all of them until they're gone, and then they will come up with new RS-25s, new and improved RS-25s. The most thrust at launch will come from the solid rocket boosters. They are pretty much the same as the space shuttle. In fact, as you can see, I'm using the space shuttle platform, and they fit directly over it. Instead of 4 segments of solid fuel, it's got 5. And just to give you an idea how big that is, here's a scale model of the Gemini Titan. This one is Gemini 4. It propelled Ed White into orbit so he could do his spacewalk. And you can see here, even the cone is bigger than the actual capsule that carried 2 astronauts. When you look at the whole rocket, you kind of take for granted how big just these solid rocket boosters are. You could use the chart, and you can see that the Artemis, which is this one, looks like it's considerably smaller than the Saturn V. Kind of get an idea where it is, but using scale models, we can, these are both the same scale. So the rest of this video I'm going to go through, and we're going to go through the various stages and compare the 2 missions. This Artemis II mission is, to me, is kind of like the Apollo 8. It's just to get to translunar injection, which is you got to go from orbit to approximately 17,000 miles per hour for an extended period of time to escape the Earth's gravitational pull, where you could drift and catch the moon's gravitational pull. You have to get a hot rod space vehicle up into orbit, 7,000 miles an hour. And the hot rod space vehicle is usually going to be fairly heavy, hence the need for the heavy lift. Both the Apollo and the Artemis have extraordinarily heavy lift. The thrust at launch for the Artemis is 8.5 million pounds. The Saturn V was, I think, a little over 7 million pounds of thrust. If I've got any modelers out there, I am not a professional modeler by any means. I just use models to kind of learn, so I'm sure you could pick apart my craftsmanship. And plus, this kit here, the faded part, is probably a 40 years old, unprotected monogram. The lower part is a newer kit from Revell. My older kit cracked so bad that I couldn't even use it. Quickly built the bottom stage, didn't paint it, anything, so that we could have a direct comparison. Someplace around 2 minutes, the boosters drop off, and now we're just with the SLS, the Space Launch System by itself, and now we're down to 2 million pounds of thrust. It burns roughly 3.5 minutes. At this point, I'm not clear because there's still a lot of sketchy information whether or not the escape tower and protective shroud go away. It should here, but you could also right here you can see the problem with the Airfix model. Even though it's 144 and got great decals, no detail at all. In fact, no Orion spacecraft. I had to make my own, but we'll stand by on that. With the Apollo, its launch, they were like really tremendous. With the Apollo 8, you didn't have the lunar module in there, so there was less weight. So we'll put that over there. The launch there, and I remember these, that was made with the first stage, which had the 5 F1 engines, which are huge. One is painted from the last model. That's all that was left. It probably only burned about a minute to 2 minutes. I can't remember. It didn't burn that long, but I remember the fire from as it burned was actually bigger than the rocket itself. Then you had the Ring of Fire and then 5 J2 engines. This model was incorrect. It did not have the protective shield. By the time you got to the second stage, the escape tower was gone. The service module and command module were fully exposed. By the time the second stage burned out, it was in orbit, and then you had the separation of the third stage. The third stage had a J2 engine, which was a very powerful engine. In fact, the RS-25 was designed kind of around it. They did an orbit and then sort of did a slingshot move. Now we'll go back to try to get to the same thing with the present model of the Airfix. I had to make my own. This is made on the wood lathe, and I will try to put this together for you, and I'll get right back. This part here is actually just panels that protect the solar panels, which I couldn't recreate. There's 2 sections here. You had the interim cryogenic propulsion stage. Uses liquid hydrogen and liquid oxygen. Rocket engine is a RS-10, which can be started and then throttled and shut down and restart. The RS-10 engine is based on the Atlas Centaur second stage. Here's the Atlas Centaur here, right here. And that was it's saying in 1962 to 1977. And so that second stage was powered by the RS-10 and was similar to this one. And that has been used on other rockets, to include the Delta IV here, which is 2008. And I think this is pretty much the same as the second stage of the Delta IV. It's got considerably less power, and now we'll do the side-by-side comparison. So we're looking at translunar injection at a capsule that's bigger. It's the Orion capsule, even though I don't have a lot of detail, in fact hardly any. I just got the general shape looking at pictures. It holds 4 astronauts, has a lot more area in it and a lot cooler equipment. Of course, the command module of the Apollo, it held 3 astronauts, and it still had plenty. It had quite a bit of room, actually. Once they did their slingshot orbit, the J2 engines fired and got it up to 17,000 miles an hour. I've seen interviews, I think it was Jim Lovell said that they were looking out the window and you could actually see the Earth get smaller as they powered out into space. From what I'm reading, the burn for Artemis is going to be longer because look at the size of the 2 engines here. You got a J2 versus a RS-10. So it's going to have to burn a little bit longer. But it's a lighter load too. The Artemis missions are going to have the lunar module, or later the Mars lander, are going to have to be launched with separate SLSs, or SpaceX has the Starship launch system. A lot of that's still up in the air, and a lot's changing even as we speak on that. But for Artemis II and the Artemis missions to the moon, you're going to get just the interim cryogenic propulsion system as the way to get to TLI. Once you get to this phase, they've reached TLI, and now it's just a matter of picking up gravitational poles and finding the right orbit path. Cryogenic propulsion stage will be separated, eventually going into deep space. At that point, you get the service module, which is made by the European Space Agency. You can see the solar panels. The main engine is just a reuse of another engine that we've seen before, and that is the OMS Orbital Maneuvering System engine that was on the space shuttle. Here is the OMS engine. It's that engine right there. And that was to get the space shuttle maneuvering around or up to different speeds once in orbit. And it had 6,000 pounds of thrust. Thought about cutting that off, but it'd be awful hard to do with wood. But your OMS engine's only going to be that big. A lot of questions for me on how they're going to, once they get into a lower lunar orbit, how's that going to have enough thrust to get out of the lunar orbit and get back? We'll leave it at that right now. If you go to the Apollo, once they made TLI, especially on Apollo 8, it just broke off and you had the command service module. Actually, the path of this mission is following an orbit similar to the Apollo 13, where they didn't have enough power to get back because the command module was damaged from an internal explosion. So they slingshot it back. That's what the Artemis mission is going to do. With the Apollo system, as it approached the Earth, you had the final separation, command module left, and then you had just the capsule. With the Orion, again, I just have to use my wood lathe to get an approximate size, but the capsule's quite a bit bigger. A lot of the information that I've gone over on the Artemis is from this little pamphlet here from a different model, the AMT-1/200 scale model of the Artemis. Is right here. It's not completed. The decals on this still need to be put on. Well, that's about it for this video on the Artemis. I'm trying to get this out before it actually launches. I hope it goes well, and I hope that this video helped understand some of the stages and the various parts of the mission. If you like this video, please press the like button and then subscribe. Thanks for watching.